A boat heads directly across a river 41 meters wide at 3.8 meters per second. The current is flowing at 2.2 meters per second. What is the resultant velocity of the boat? How much time does it take the boat to cross the river? And how far downstream is the boat when it reaches the other side? So, let the width of the river is d. It is equal to 41 meters. The speed of the boat, VB, is 3.8 meters per second. And the speed of current is 2.2 meters per second. What is the resultant velocity of the boat? Let's write it as V absolute velocity. So we should find both magnitude and direction of this vector. The second question: how much time does it take the boat to cross the river? Time we have to find. And at last, how far downstream is the boat when it reaches the other side? Let L is downstream drift. Let's start with a picture. Both sides of the river banks. Current flows to the right. Width D is known, 41 meters. And let boat starts from this point, and according to the condition, a boat heads directly across a river. Directly across a river. So the vector of boat's velocity is directly directed to the opposite bank of the river. This vector is VB, the velocity of the boat. At the same time, the current drifts this boat downstream at a speed vc. So absolute velocity Vabs is the vector sum of two velocities. Velocity of the boat relative to the stream plus velocity of the stream, of the current, relative to the Earth. These two vectors we have to add, for example, using the rule of triangles for addition of vectors. So V current is here. The resultant velocity, absolute velocity, is this vector V abs. We can find the magnitude of absolute velocity using Pythagorean theorem. In this right triangle, VB and VC, speed of current and speed of boat are legs of right triangle, so hypotenuse can be found using Pythagorean theorem. V absolute equals square root VB squared plus V current squared. This formula is ready for use to find the magnitude of absolute velocity. The direction of this vector can be defined by an angle alpha between direction of the boat relative to the water, and absolute velocity. From this right triangle, we can write tangent alpha equals opposite leg divided by adjacent leg. V current over V boat. So alpha is inverse tangent of ratio VC divided by VB. The next formula. So we have full information about absolute velocity. Now, concerning time. Imagine you are a boatman. You are sitting in the boat and you see that opposite bank of the river approaches you at a speed VB. The distance is d, the speed is VB, so we can write that t, time, equals d over VB, d over VB. And the last question, how far downstream is the boat when it reaches the other side of the river? Okay, this vector shows both magnitude and direction of the motion of the boat with respect to the Earth. So, where the boat goes, there it gets. So this is displacement of the boat, and this is L, downstream shift. Downstream shift. We have two similar triangles. One triangle is triangle formed with leg D, leg displacement and hypotenuse displacement, and the opposite to the alpha leg is downstream shift. This is the first triangle. This triangle is similar to the triangle of velocities. So we can write down this equation. L over D equals VC over VB. The corresponding sides of two similar triangles. From here we get L equals d times VC divided by VB. So that's it. Now let us make calculations. Absolute velocity, magnitude of this vector, or absolute speed. V absolute equals root of 3.8 squared plus 2.2 squared meters per second equals, let's use the calculator, root 3.8 squared plus 2.2 squared. We get 4.3908999 meters per second. But in the condition of a problem, we have two significant digits. So we must to round up the result to two significant digits. After rounding up, we have 4.4. 4.4 meters per second. The next, alpha. Alpha, it's inverse tangent of 2.2 over 3.8 equals shift tangent 2.2 over 3.8 gives 30.06856 and so on. We must to round it up to two significant digits. Two significant digits. 30 degrees. The next, time t. T equals 41 meter divided by 3.8 meters per second gives 41 over 3.8 gives 10.78947. Two significant digits. After rounding up to two significant digits, we have 11 seconds. And at last, downstream shift equals 41 meter times VC, velocity of current, speed of current, 2.2 meters per second, over speed of the boat, 3.8 meters per second, gives 41 times 2.2 over 3.8. 23.7368 and so on. After rounding up, we must write two significant digits, two significant digits, 24 meters. The problem is solved.